Hello, my name is Ron St. Denis and I'm with Acuity Solutions. I'd like to take a second to thank you for watching this video and also for visiting Acuity Solutions website. During the course of this video, I'd like to talk about three individual 5-axis cutter path operations that are available in NX. Variable surface contouring, contour profiling, and sequential mill. Okay, so what we have here is a fresh manufacturing part file that has both the machine geometry and the blank geometry in it. I'll show you that, but I'll go to the geometry view. We'll look at the workpiece. I'll display, there's the machine geometry, and here's the blank. Our machine coordinate system is at the center of the ring, and also even at the base. So we'll go to the tool view. I've created several tools here: 1-inch ball, a 1/2-inch ball, 750, a 3/4 inch ball, and a 3/4 inch flat bottom with 125 corner radius. So we'll go back to the operation, and we're going to create a variable axis surface contouring operation. So we'll go to create operation, mill multi-axis. Here's your variable contour. We'll put it in program 1, 2, 3, 4. We'll start with a 1-inch ball end mill. We'll bring the workpiece into play, and we'll use mill rough, which puts like 30,000 stock on the bottom. We're not going to worry about naming it at this point. We want to get right to business. So there's a number of drive methods here: boundary, curve point, spiral, surface area. The surface area is a drive method that it requires probably the least amount of input, and it still offers a considerable amount of flexibility. So we're going to first thing we're going to do, working from the top down always in these dialogues, we're going to specify the drive geometry, which is this bottom surface here. It's like a spherical surface somewhat. So we're going to drive that geometry. We're going to try to keep the tool axis, or we're going to keep the tool axis normal to that geometry. So we picked a drive geometry. Now this surface area, if we select surface area here, this allows you to pick the percentage of surface that you want to cut. So this is how it determines how many drive points and where to put the drive points. So we're going to leave this at 100% on each crossover as it is, start and finish, 0 to 100, and we'll come back and edit this afterwards. So we're gonna choose, working down once again, we're gonna choose the zigzag pattern. We'll change the step over to scallop height, and we're gonna cut this down to 20 thousandths. 100 thousandths a little bit much. So working down from there, the projection vector. Now the tool axis. Although that sounds good, you really it'll give you an error if you do this because it doesn't know the surface geometry at this point. So we're going to say normal to the drive surface. We're going to tell it to project it normal to the drive surface. That's tooling information, and the tool axis is going to be normal to the part. So we've got opposing vectors here really, and that's what we want at this point. So we'll go with that. And let's see, I think we're ready to go. So we're going to, we'll try this. So when it looks along the projection vector, it sees, it can see, because with the tool axis vector, it can see, with the tool axis vector normal to the drive surface, it can see points way out here, which get way up into the boss segments, which is really not what we want at this point. So we're going to go back into surface area the drive method. We're going to edit the surface area, and we're going to drop this down, and we're going to pick surface area again, and we're going to change these surface percentages. So we're going to start. Let's start at 8%, and we'll go to like 92% on each crossover. So we're going to cut it down to about 84% of the total. And we'll regenerate again. And so now you can see where it comes inside of here and doesn't get into the bosses. So when I do 5-axis cutter paths, I personally prefer my engages and my retracts linear, and we'll go linear normal to part because that's what our tool axis vector is. And we'll leave the retract will be the same as the engage. It keeps it simple and clean. So now, although it does look like it is drilling, at least in 5-axis, we know where it's going to be coming from. It'll be clear of the work at least. We can make that any length we want, of course. Well, let's do that. All right, so now we know we're at least clear of the work. So we'll go into a 3D dynamic verification here. We'll cut the speed down to 1. So no, we don't have to be down to 1. Let's go. So now, in 5-axis mode, we've managed to remove quite a bit of material here. But even with a 1-inch ball unmill, that's still quite a healthy cut. So we're going to go into cutting parameters. And we'll do multiple passes. We'll do a multi-depth cut. The part stock offset, that's the amount of stock that you're starting with. I know that these sidewalls are somewhere between 1/2 and 1 inch, so we're going to start at 600. And we'll go number of passes. We'll make 4 passes to get to the bottom. We'll generate that. So let's just verify this and see what this looks like. I think that's a little bit more reasonable. Now you notice that the tool is climbing up the flanges a little bit on a couple of passes. We could actually reduce the surface percentage a little bit more, but we're going to let this go for now. This is not going to hurt anything. It's not going to violate the part, and it'll have some extra material out of there for later. So we're going to leave that as it is. I'm going to say OK to this and save the cutter path. Now I think we'll rename this. We'll call this rough pocket. And we're going to copy that. We're going to paste it. We'll call this finish pocket. And so all we have to do is go in here and edit. We'll remove multiple passes. We'll turn off multi-depth cut. Say OK to that. We'll change this to mill finish. Because at mill rough, we're leaving 30,000 stock. Okay, we're going to say this mill finish, and that'll bring us down to 0 stock. If we go back in here and look. Yep. And we'll finish the bottom. So that's what it looks like. And we'll do a quick verification of that. Oh, the one thing we didn't do, we need to edit the surface area because the scallop height is generated from here. So we're going to knock that down. This is going to create a little bit of extra cutter path. So there we are. Okay, so of course you can always, everybody has their own personal preferences, and you're going to, once you get going on this, I'm sure that you work on that some more to perfect it a little bit more. So next we want to generate, what we want to do is we want to side cut the walls all the way around to really get into these corners in here. So a quick and easy method of doing that would be we'll create another operation. This time we'll use a contour profile. Same thing. We're going to we'll go to a smaller ball end mill here. We'll go to a 3/4 inch ball end mill. We'll leave the work base, and we're going to use mill finish on this. So on this, we'll look at the part. So once again, we got to specify the floor here. And we're gonna look to see the walls, and it's gonna pick the walls for us. So you see, it shows you a boundary inside here. So it's going to attempt to do this pocket all the way around. And that's pretty much what we're looking for. So we're going to, and there you have a pass. It goes all the way around and overlaps. So we're going to do a quick verification on this. So you can see it removes a lot of stock, but you can see there's some little nubs left in here. So to clean some of that stock out of those corners, we can actually do additional passes, side passes, and you do that from cutting parameters here. Same multiple passes, multiple side passes, multiple depths. We're just going to do multiple side passes. So side offset stock is the same. It tells you how much stock you're starting with, right? So we're going to start with start with 200 thousandths. And we'll go multiple passes, and we'll do that in 4 passes. Now let's try 3 passes. It's doing a little thinking here because it has to offset the geometry. And there you have 3 passes. We'll do a quick verification of that. Now I know that this part has these are 1/4 inch radius in the corners here, so we really need to get in there with something smaller. So, and I'm going to use that. So we'll say I'll take K to that, and I'm going to call that semi-finish swerve. So I'm going to use this opportunity to demonstrate sequential mill. Most of the material out of this pocket, I'm going to demonstrate sequential mill. Sequential mill requires a lot more programmer input, but it also offers quite a bit of flexibility in that you will control every segment of this cutter path. So the motion of the cutter path is entirely up to you. So and it's all about part surface, drive surface, and check surface. I don't know if you've ever programmed in APT, Automatic Part Tool Programming Language, you'll know, you'll be really familiar with part surface, drive surface, check surface. Part surface is where the end of the tool goes. The drive surface is the surface that you want to drive with the side of the tool, and the check surface is where you want to stop with the side, the center, whatever. So I've created an additional face here that's halfway between these two slots, these two bosses. And the reason that I did that is because I like to start, of course, away from a boss. I don't want to start in a corner, especially if especially here because most of the stock is in there. So this is just a sheet body that I've created with one curve on a plane that's tangent to the outside of this part at an angle. So you can, if you create this cutter path starting on this and ending on this surface, you can actually make this cutter path a lot shorter just by going into the part in modeling and moving this plane to a different angle. And the cutter paths will be, because it's fully associative, the color paths will be modified to that. So we're gonna create a sequential mill cutter path. Same program. We're going to use a 1/2-inch ball end mill this time, and we're going to use the workpiece, and we're going to use the finish mill finish. So the first thing I want to do is I want to make sure that we display the tool because it makes it a lot easier here because you really want to see where the tool is going. Of course, starting at the top down again, we have in towel, out towel, and the normal global parameters that you set in every cutter path. You also have avoidance geometry. We'll just go in here and look real quick. You can create a from port, a start point, return point, go home, clearance plane, and all of the basic stuff. So we're not going to do that for this demonstration. We're just going to move on. And of course, you can have start a path event, end a path events in here, and you can default your feed rates and corner controls here. So once you have everything set here, we're going to go right into it. So here, what you're going to do is you're going to build a step-by-step cutter path from the top up here. So we're not going to put any engage in. What we're going to do is we're going to pick a reference point somewhere over here, and I'm going to put it at minus 12, 3, 10. So what I have here is I've created a point here that so that it'll reference from here. It'll go to here, and then it'll know, you need to know where you're at when you get started because you're going to say near side, far side, or on for each surface that you pick. So it needs to know where the cutter path is starting from. So we'll pick that, and we're going to say the tool axis. We'll leave the tool axis for the first cutter. First motion will be there, but we're going to go to 5-axis fan with a tool axis. So now the only thing we have to do is you see this geometry button here. This button is, you have to do this button on this dialog comes up every time. It refreshes itself every time you finish picking geometry. So, or every time you OK to the next step. So here we are, part surface, drive surface, check surface. I'm going to pick faces, and I'm going to go to on the drive surface, that's where you put the side of the tool. I'm going to stay on the near side in reference to this point. So I'm going to pick this as the drive surface. It's looking for the part surface, also the face on the near side. There's your part surface. Now the check surface, I'm going to say face also, but I'm going to put it on the surface. And I'm going to pick that surface. So now we're back to the dialog, and you see here the geometry. It says the drive surface, the part surface, and check surface have been picked. So we say OK here, and we get the tool. is there. And we also get a vector. This tells us which direction the tool wants to go next. So once again, we get back to this dialog. We have a tool. You can see there's a step up here. And it's asking for, we don't have any check surface defined. So now we're just looking for check surfaces. So now we want to be 5-axis fan here. So we're going to go in, we're going to pick a face. We're going to change this to near side because we only want to go to the near side, and we're going to drive over to here. Say OK. Say OK again, and the tool fans over there. So once again, it's looking for a check surface. Check surface is not defined. We're going to pick the check surface. We're going to stay on the near side as well. We're going to go over to here because I know these are all the same. These radius are the same as the tool. Say OK. OK again. It fans over to there. Once again, we're looking for a check surface. We're going to pick a face. We're going to be on the near side. I'm going to go to this face over here. And the tool fans around there. So you can do 3-axis cutter paths with this as well. But there's a lot of other better options. But this can be handy when you want to just do one pass. You just want to notch out a corner or something like that. This can be very handy. So once again, check surface, face, near side. We're going to go to here. So if you look at this, you'll see that these two, the drive surface, it converts the previous check surface becomes the drive surface, and that's exactly how it works all the way around. Unless we stop. Now, if we go up here and we stop on this surface that I created here, and we want to continue on, then we have to then we have to say that the drive surface is the previous drive surface and not the check surface. But that's selectable right here. So we're going to go to check surface. This time we're going to go on because we want to stop it here. We're going to pick this. We're going to say OK. And the tool fans right to there. So now we've done half of this. Now because I put this plane right in the middle, you could mirror this cutter path about this and do both sides this way, or we could continue on and go right around. So we're going to continue on and go right around. So now the drive surface is not the previous check surface, it's actually the previous drive surface. And now we have to pick a check surface. And we're going to be on the near side, and we're going to go to here. Whoop. That's what you don't want to see. Oh, so what happened here is because it was going to make the check surface the new drive surface, the vector is coming down this way. So we need to pick a vector. We're going to go to a point. We're just going to pick an end point down here. And we're going to try that. There you go. So moving on. Next check surface, near side, face. Next check surface, near side, face. Next check surface, face, near side. Okay, so we got one more leg to go, and I'm going to go past this surface this time, so I'm going to go to the far side so that we have a little overlap here. Pick the check surface, face. We're going to go to the far side. Okay, there you go. So now when you get all the way around, or when you want to end the cut, you just say end operation here. Say OK. Now remember, your avoidance geometry is not done here. So but you would want to do that before you get started with this. I just wanted to get this to the point where I could show you the results. And there it is. Of course, there's still a few little nubs in here that you need to clean out, but we just got a 5-axis cutter path all the way around with Sequential Mill. So that's all I have for now. Once again, I'd like to thank you for watching this video, and thanks for joining us on our on the Acuity Solutions website. Hope you found this enjoyable and useful. Thanks again.